Hey gang, so this is the Unit 5 Part 2 review, but it's basically exponential functions review. So we had another review. I'm going to go ahead and just do one real quick with y'all and see if I can get it going for y'all. Alright, so first thing we're going to be sure we know how to do is to graph exponential functions. I'm going to do this one. I'm not going to do everything on here because it's just kind of basic. First off, if I give you this, I'm going to tell you that the A, remember, we have the equation y equals ab to the x power. So the a value would be 2. The b value would be 1/3. Simple as that. I would take it if I want to graph it. Usually I do -2, -1, 0, 1, and 2. That's like the most common things that I'll do when I work these. I'm going to take it and I'm going to put 2 parentheses alpha y equals 1/3 parentheses house top x power. Okay, I'm going to go to second table, and I'm going to go up to -2, which is 18. 1 is 6, 0 is 2, 1 is 2/3, and 2 is 2/9. Okay, so if I were to graph this, which is what it's asking me to, -2, so 1, 2, and then 18 would be, let's see, 15, 16, 17, 18 would be right here. -1 and 6 is going to be right here. 0 and 2. I don't really need to know the rest of it. I just kind of need to know what it's doing because they all kind of look the same. It's going to come down and it's going to hug that line right there. When I graph, remember, I always ask that you label that asymptote nice and clear. So put that dashed line. When it's zooming in and trying to play the I'm not touching you game. Alright, and that's how you graph. If you want to graph that one, you can. I'm going to go ahead and look at this one. Identify the domain and range of the function. Make sure you provide these answers using inequalities. Okay, so I'm going to take a function. Here's what I'm going to do. I'm going to go y equals. I'm going to put it in my calculator. 3 parentheses 2 house top x. And I'm going to graph it. Alright, so there's my graph. Hold on one second. Alright, so it's going to have arrows, right, going forever and ever and ever this way, and forever and ever this way. So when I look at this, I can see that the domain, it goes forever and ever and ever, wider and wider and wider and wider and wider and wider. So that means it goes from negative infinity, less than x, less than positive infinity. Or remember the other way we could write that is all real numbers. Or remember we had that fancy double R that we could write. Now here's the thing. When I graph every single one of these, they're all going to look really familiar. Not familiar, similar. They're all going to look kind of the same. The domain on an exponential function, if it's just graphing it, it's not like a real world problem. That changes things. If I just give you a function and I say, oh, this is exponential, can you graph it? What's the domain? You know what? This is always it's always going to be all real numbers. So I could sit and go through each one of these and show you that it's going forever and ever, ever this way, and forever and ever, ever this way. All real numbers. But I think I'm just going to show you one. Now, this is the first one that we're doing. I need to look at the range. How tall is it? Oh, how tall is this getting? Well, I can see that I don't have any graph down here. All my graph is up here in quadrant 1 and 2. This graph is swooping down. It's going forever this way, right? That's going to positive infinity. But it's coming down and it's getting really, really close. But it never reaches 0. Right here. It looks like it does, doesn't it? But it doesn't. It's playing the I'm not touching you game. So, if I were to go to second table, here's another way to look at it. I could hold this down on the x-axis, the x values. I could go for like hours just holding this down. And I would never reach a value that it stops at. I could go the other way for forever and ever and ever. I could hold it. It's never going to reach a positive number that it's not going to keep going up. It's every single number that I can think of for x. The flip side of that, though, is the domain, or the range. This over here. This is getting bigger and bigger and bigger and bigger. So the boundary on this side, let me think of it like this. On the positive side is forever and ever and ever up. But over here on, as it's going the other way, it's getting smaller and smaller and smaller. 0.02, 0.01, 0.005. Look, it's getting really, really tiny and really close to 0, but it never reaches it. I can hold it down for a really, really, really long time, but I never reach 0. This right here says -10, e to the -10. That means I have 0.00000000007. Oh my goodness, that's like really, really tiny. And if I go again and keep going up, now I'm at e to the -13. 0.00000000000. I think you get my point. It's pretty close, but it never reaches it. So let's talk about that. The low number is 0. It never reaches it, so you don't put the line under it. The y, and then it goes forever to positive infinity. Now remember we talked about this. We're not really going to see it written like this. Remember how we can cover this part up, the infinity part? When you have a double boundary like this, you can cover up this side and read it backwards or forward. 0 is less than y, or reverse those and say y, it's opening up to y, so we're going to say open up to y, and then 0. Y is greater than 0. Just read it backwards. Either one of those mean the same thing. So when you put that double boundary on there, if you have a number on one side and infinity on the other, then you can kind of redo it. So let's just take the domain of this, or the range of this next one. Let's put this in here. Let's put 7 parentheses 0.3 parenthesis housetop x. Now let's look at it. All right, let's hit graph it. Let's take a look at it. All right, so here it comes down. So again, the domain, however wide, it's going forever, but this is starting up at positive infinity, and as it comes down, it's getting really, really close to 0. It's not ever going to reach it, but it's getting super close. So we're going to look at, again, 0 is the low number, all the way out to positive infinity. So I would basically say y is every value that's up here. So y is always bigger than 0. So y is, I'm going to cross this off, 0 is less than y, or y is bigger than 0. All right, so that's kind of a domain and range. Let's look at number 4. In the 2000, the population of Massachusetts was 6.3 million people. It was growing. Keyword there, growing. At a rate of 0.32% each year. 0.32% is not very much when you think about it. That's the percentage. Normally we say like 5%, 10%, something like that. This is not even a half of a percent. Half of 1%. It's not even that. Okay? At this growth rate, here's the function they got. They said that they represent this with f of x equals 6.3 times 1.0032x. So they are giving you the function. It gives the population after 2000. Using this model, we're going to call this the model, describe the domain and range. Sketch the graph if you need it. All right, let's sketch it. Let's see what you remember. We did this in class today in my 5th block. 6.3, what does that represent? That is the A. A is the Y-intercept. It's also the starting amount. So that means that if I were to label this 6.3 right there, that is the starting amount. Now here's my question. This town is growing. It's not very much, right? 0.32, but it's still growing. So it doesn't even matter what this is. I just need to know that it's growing. If it's growing, that means it's going to look like this, right? So let's talk about the domain and range of this situation, this scenario. So when I look at the domain, normally I would say, oh, it goes forever and ever both ways, but this doesn't. This stops right here. Okay, so that means I'm going to look at the domain, which is the x. If I'm a bug here on the x-axis, I can go forever this way, oh, but then I get stopped right here. That value is 0. But this direction, I can go forever and ever and ever and ever. Okay, it's going to go forever. This is going to keep going up and getting wider and wider and wider, which means it goes forever and ever this direction. So this boundary is 0, less than x, less than forever this way, positive infinity. Now I could, remember, when we have an infinity and a 0, we can mark these off. And I would say 0 is less than x, or read it backwards, x is greater than 0. On the range, how tall is it? Well, the range, normally we have that 0 boundary, but the graph isn't down here. The graph starts right here. The graph starts at 6.3 and it goes up, right? So that means my lowest value is 6.3. Oops, less than y, less than how far up does it go? It could go up to infinity. That'd be a really big town. So what we're going to say is we're going to mark this side off, and we'll just simply say that 6.3 is less than y, or y is bigger than 6.3. So this is the only situation when you get these real world problems where your domain is going to change a little bit. All right, so let's go over here. Let's look at number 5. You've got one kind of similar to this on your test, which is why we kind of put this one on here. An animal reserve can use the following equation. So on this one, you don't have to come up with it. We're going to give it to you. This is going to determine the population of elk. I think on your test, I'm going to tell you moose. What is the A value, and what does it represent? Well, I have asked you this over and over. A is the Y-intercept. It's the starting amount. In this situation, the A value is 20,000. And what does it represent? How many elk you have on day 1, or how many elk are currently in the reservation. However you want to word it. It's the number of elk at a certain time. What is the B value? So the B value in this would be 1.08. What does that represent? Okay. So this 1 right here in the front means that it is growing, right? This represents something growing. How much is it growing by? Look over here. That would be, move your decimal back, it would be 8%. Growing 8% each year. Was it year? Population of elk in the reserve. Animal reserve can use the equation of population of elk in, oh, it doesn't say. Growing 8% each, I'll just put year and we'll put question mark because I'm not sure what it's growing at. All right, that's what it represents. Okay, so 6, the function f of x equals a 3 to the x power is an exponential growth function. Which statement of a is true? Okay, so let's look at this. Because f of x is an exponential growth function, okay, so we know it's a growth function, which means it's going to look like this, or it's going to look like this. Both of those are growing. This one's growing positive, this one's growing negative. Because it's an exponential growth function, a has to be positive. Okay, so make up a scenario, 3 to the x, and let's make a not positive. Let's make a negative 2. It says that it has to be positive, so let's see. So I'm going to go here, y equals negative 2, 3, parenthesis, housetop, x. Is that right? All right, let's graph it. It says that because it is an exponential growth, a must be positive. Well, if a is negative, is this still growing? Yeah, it is. So just because it's negative, that's not true. Because f of x is exponential growth, a has to be positive. Well, if a is positive, it would grow in a positive fashion. But if a is negative, it's still a growth. So this one's wrong. That's not true. So let's go to the next one. Because it's an exponential growth, a must be greater than 1. So we're going to say f of x equals, pick a value of a bigger than 1. I don't know, let's pick 4. Okay, so now we're going to make it 4. So we're going to say 4, parenthesis, 3, housetop, x. Did I put all that in right? Okay. Okay, because it's an exponential growth function, a must be greater than 1. Okay, If it's bigger than 1, yeah, that's absolutely true. So this is true. It did give us a true statement. What happened when we had a number less than 1? You're like, wait, okay, now what? So we're trying to make this not true. If I have -2, didn't we just do that one? Hang with me. I know this is a confusing question. When I made it less than 1, so it says it has to be greater than 1. But you know what? If it's less than 1, I still get a true growth function. Because it's an exponential. So you know what? That one's not true either. Because it does need to be greater than 1, but it could also be less than 1. Because it's a growth function, a should never be negative. Well, we just proved that wrong right here. Our a is negative, and when we graph it, we still get a growth function, so that one's not right. All right, let's try this. The function represents exponential growth because 3 is bigger than 1. So a can have any value. I'm thinking that's probably it, but let's try it. 3 is bigger than 1. Let's try a value. Let's put like -2. And then let's put it where the 3 is smaller than 1. So y equals -2 times alpha y equals. Oh, thank you. That was my son on the video there. House top X. Oh yeah, you borrow that one. I'm going to graph it. Oh, and look at that. So now I changed the a value to be less than 1. Read from right to left. This becomes a decay function, doesn't it? Look at that. That becomes decay. So you know what? If you go less than 1, between 0 and 1 like a fraction, it becomes a decay. So the function is exponential growth because 3 is bigger than 1. So it can have any number value that you want. So it is going to be D. I don't think there's one that confusing on your test. I know that one was like, what's going on there? Okay, identify the constant factor a for this exponential function. So a right here is missing. If it's not there, it's understood that it's a 1. So a would be 1. The function here can be used to determine the value of used motorcycle Fords over X years. What is the Y-intercept? All right. What is the Y-intercept? The Y-intercept is A. What is the A value in that situation? 12,500. What does it represent? The starting amount. The amount the motorcycle was worth in the beginning. A town has a population of all those residents, and the town council offered a prize for the best prediction of how long it will take the population to reach 100,000. The population has a growth rate increasing of 6%. All right, so here we go. Y equals starting amount. Starting amount on this situation is 78,918. We are growing, so that means we're going to do 100, and since we're growing, we're going to do plus. We're doing 6%. 100 plus 6% is 106%. But I can't put that into my calculator like that, so I have to move my decimal over, and it becomes 1.06. So back over here, I need to put what? That ratio, 1.06 to the x power. Now they want to know, when are we going to be 100,000 people? So this is kind of a look and guess type situation. I'm going to take 78,918 times 1.06 to the x power. Now, I don't want to graph it because 78,000, hello. If you try to graph that, that is going to be like way up there. The starting amount of that is way, way, way up there. And I probably jinxed my calculator. It's probably going to be overwhelmed while it tries to graph that. Oh, there it goes. It's done. And yeah, you certainly can't see it. And it doesn't make any sense to look there. I can't see 100,000. So I'm going to go to the table. And, oh, let me go back to here to table 1. All right, so my starting amount is 78,918. I want to know, when am I going to be at 100,000? Oh, looky here. When's it going to be? It's going to be sometime between year 4 and 5. Maybe year 4.1. How could I figure out exactly? I could do this. I could say 78,918 times 1.06. I know it's between 4 and 5, right? Let me put to the 4.3. That's a little bit more than 4. Look at that. I'm at 101,000. Let me try something lower. 78,918, parenthesis 1.06, housetop. Let's do 4.1. Looky there. Right, it is almost at 4, isn't it? 4.1, maybe somewhere right around in there. It's going to be that 100,000. So I'm going to say about year 4. If you wanted to get real precise, I might say 4.1. But 4 works. All right. The graph below represents the number of daily visitors and weeks. Write an exponential function for this situation. All right. If I give you a graph and I ask you to create or to write an exponential function, first thing you could look at is you could see that 50 right there. Correct? That's 50. So that means my A is 50. But I don't know how fast it's growing. I don't know what it's doing here. So here's what I would recommend. I would write down these ordered pairs. That is 0, 50. This one right here is over 1, up 100. This one is over 2, up 200. Over 3, up 400. And if I know those, then I can actually go here. Well, I'm going to leave those because those are ones I need. And I'm going to put these in. I'm going to go back to stat, calculate 0, and I'm just going to hit enter. There it is. A is 50, which I already knew it was 50, but I now know by looking that B is 2. Now we don't care about R squared and R. If I have this, I know that Y equals AB to the X power. So Y equals A times B to the X power. And there it is. So given a graph, just create a table and do stat edit. Pretty easy. All right, let's set this one up, and I'll let you solve it if you want. An animal reserve has 20,000 elk. So how many elk am I starting with? What's my starting amount? That is my A value. It's increasing 8%. So that means if I'm increasing, I'm going to add 8%. So that's 108%. Can't put that in. I got to fix it. Make it 1.08. There you go. Y equals 20,000 times 1.08 to the X power. When is it going to reach 40,000? Well, I'm going to have to put that in my calculator. Y equals, and I'll do it on mine so you can follow along, but I won't tell you the answer. 2023 times 1.08 to the X power, right? I'm going to go to second table. I'm starting with 20,000, and they want to know when does it reach 40. So I'm going to put that right there and let you look at it and see if you can figure out between what 2 years it actually reaches 40,000. All right. Let's take a look at 14. What is the asymptote for this exponential function? So the asymptote is the line that it swoops in and gets really, really close to, but it never touches. And I can see that that is right here. It's getting really, really close to that line. 1, 2, 3. So that is at 3. Asymptotes have a y in them, which means the asymptotes are y equals. What value does it get really close to? 3. Two exponential functions graphed below share a common asymptote. What is the equation of the asymptote? Well, that's that line right here that they're getting really, really close to. Here is the 0, 0, so this is 1. So that means asymptote has the letter y. Right here at 1 is the line they're swooping in, but never touching. They share that one right there. They do share one here. We don't talk about vertical asymptotes yet, but if you notice that, there is one there. On the coordinate grid, P represents the amount of money in Paola's savings account, and V represents Vincent's amount. Who had the higher initial deposit? Okay, so we're looking here. This is Vincent. This is Paola. Was it? Yeah, Paola. Who initially invested the most? Hopefully you're looking at that and going, well, Vincent initially invested 400, so Vincent did. All right. Table shows the population of a small farming community since the year 2000. The Y-intercept of this situation, what is it? All right, the Y-intercept. That's the 0. Okay. So it's 5,005. What does it represent? A is, and I'm going to put A equals here. A is the Y-intercept, and it's also the starting amount. That's the key words we are going to look for when you have to write something down on this, the starting amount. All right, given this situation, label the following. The asymptote. Well, you know what? If you graph this, it's going to look like this. Something like that. It's going to swoop in and almost touch this line right here, which is y equals, that's the x-axis, 0. Just don't forget to tell me y equals. Where does it intercept? Well, remember, this one you're not going to be able to see on your calculator if you try it. Remember, it's y equals ab to the x, and a is the y-intercept. What is the a value here? Hopefully you said 2/3. All right. My markers. Maybe that's the time and this time. All right. First block, if you're watching this on the day my sub is there, we are almost done. All right, here we go. You are going to take this. You are going to put this into your calculator, every bit of it. Where do I go, Mrs. Dean? I'm so confused. Go to Stat, Edit, hit Enter. Okay. I've already got 0, 1, 2, 3. I'm going to keep going. 4, 5, 6, 7, 8, 9, 10. Can you do it too? Or you can just watch me. 25, 1, 2, 3. 21, 4, 6, 2. 17, 881.88. 15.506.66. Oh, error. Oh, man. Stat, edit. 17,882. 15,506. Oh, it's rounding. I didn't even catch that. 12,919.65. 11,203.56. 9,523.03. 7,934.28. 6. Oh my gosh, all these numbers, y'all. This is the only part bad about regressions is all the numbers. One more. 4872.64. Okay, hopefully I got all those in there. Oh my goodness. All right, write an exponential function. Stat edit, stat calculate. 0. Enter, enter, enter. When I get to store, well, let's just see what it comes out to be. All right, so this one is not very nice, is it? Here's what I'm going to do. I'm going to say y equals ab to the x power. So 25101.47 times b, which is 0.8. I'm going to go 4 decimals out. 493 to the x power. All right, so there it is right there. The owner plans to sell the car when it reaches 10% of its original value. Okay. How long will she have before, how long, oh my gosh, how long will she have owned the car when she sells it? Okay, well, we've got our function, second quit. We have to figure out, she wants it to be when the car reaches 10% of its original value. So if I have 25,000, what is 10% of that? Hopefully you kind of already knew it's 2,500. So I need to look and see, when do I see 2,500 over here? What number do I see right here? Okay, now I did write that down, but I'm going to remind you what you could have done, because that's a lot of writing. Who wants to do all that? Enter, enter, enter. When you get right here to store, remember, just like a fraction, alpha y equals. But you don't want this. You don't even know what that is. Keep going over. But this Y1, you know that Y1 is that button right there. So hit enter, and it'll put Y1. Oh my goodness, how did I do that again? Alpha Y equals Y bars. You're going to go right there, okay? That's what you want. Enter again and calculate it. Now, all that junk right there, if you hit Y equals, it has stored it for you. So I'm going to go to second table. I want to know, when is my car worth a mere $2,500? How old is my car? There it is right there. How many years will I have had the car? About 14 years. How long will she have owned the car? About 14. And you know what? I'm going to even put about 14 years. All right, we're at 31 minutes. We got time. First block. Come on, you can do it. Fifth block, too, if you're watching it. You've got this. All right, the table shows the monthly membership in an online gaming club. Write the exponential function. I'm going to let you do it. This is all you, man. You are going to take this and you are going to, remember, we're going to go to Stat, Edit. You're going to go all the way up and hit Clear, and then move back down, and it will clear out those columns for you. Move up, hit Clear, move down. Okay? Punch that in. It's going to give you your A and your B, and you're going to write the equation. Remember, alpha Y equals, when you get to the store, it will help you save that equation. And then you're going to look, when will there be 3,000 members? When will there be 3,000 in the Y column? All right, pause your video while you do that. I'm going to go down here and do this one. Animal Reserve has 20,000 elk. Oh my goodness, my starting amount of elk is 20,000. Who wants 20,000 elk? That's just insane. My niece just got a job in Yellowstone. She'll be working there this summer. Maybe she wants to see 20,000 elk. I don't know, maybe that's a good thing. The population is in. Did we not just do this problem? Hey, hold that thought. Didn't we do this? Oh, here it was. Yeah, didn't we do this problem? Look at that. That is the same problem. Elk and all, 20,000 starting amount. Okay, this is just it written in a different form. Let's see if we get the same answer. It's increasing 8%. So if it's increasing, we always start at 100. Increasing means we're adding 8. What is 100 plus 8? That would be 108. Make it a decimal. Move it over 1.08. Here we go. Y equals the starting amount times 1.08 to the x power. How long until they reach 40,000? Put that in your calculator. Go down your column, and you're looking, when do you see 40,000 over here? When do you see it? So you're going to scroll down and see if you can see it. All right, which function best models the data in the table below? All right, super easy. Here's what we're going to do. We're going to go to Y equals. We're going to clear out that mess. We're going to do 16x plus 2.6. We're going to go to second table. We're going to go to 0. Do you see 2.6 there? I see 15. So definitely not the first one. Let's go to number 2. Y equals. Clear it out. 2.6 parenthesis 16 parenthesis housetop x. Second table. All right. I still see 0, 2.6. 0, let me think about that. 0 is this right here. This represents the starting amount. So the starting amount is 15. That means if the starting amount is 15, then my first number right here is A, which is 15. It can't be that one. It can't be that one. I bet this one's the closest to 15. I'm going to go to that one and try it. Y equals 16 parenthesis 2.6 parenthesis housetop x. All right, we're going to go to second table. 16. 41.6, 42.5. 108, 108. 264, 281. 688, 731. Which one models? Model means it's close. It doesn't have to be exact. You know what? That one right there is really close. 688 and 731 are a bit off, But I bet this one right here is not even close. Not like that other one is. I might just throw it in there just to be sure. Oh, there we go. There's 16 again. Oh, but 18. Sorry, 18.6. I got the hiccups. Now, 21.2 instead of 108. No, it's not that one. So that's the best one. All right, y'all. So the next video is going to be me reviewing a couple of things, kind of like your pre-test video. Put your name on this. Turn it into my box. Thanks for watching, y'all.